Welcome again to the October edition, the end of the 2020 monsoon edition of the Southwest Climate Podcast. As always, an optimistic or pessimistic Mike Crimmins. Mike?
Not in a good spot, Zach.
These have become a little bit of therapy sessions for me. You know, it's good to get back together and boy, I'm really happy. I'm actually excited that this is the last time that we have to talk about the 2020 monsoon.
I am too. I was actually thinking, I didn't even want to talk about it at all today. It's so far in the rearview mirror. It's almost like we did the recap last month anyways.
That's when I was prepping for this, that's kind of what I felt like as well. So we're not going to belabor it, but we do have another month of the monsoon to recap. But
due diligence.
It's not like much happened in the last month. Let's start with, we do have the final results for the Monsoon Fantasy Game, and I want to report on those. And then we'll move into a little bit of the monsoon recap and talk a little bit about whether or not we should feel gloom and doom for the fall and winter. How about that for a teaser?
Nothing but cheery messages and stories from our podcast.
So stick around. I've been listening to a lot of sports radio. They do really well at teasing before the long commercial break. So, so we'll get to that too. We'll talk about some of the conditions that are on the near-term horizon. Okay, Mike, congratulations. Between the three of us, you once again showed your monsoon and climatological prowess by winning our bet. And I think both Ben and I owe you a 4-pack. What do you guys drink in Michigan? Is it like Coors or Natty Light or?
Actually, a case of Busch Light would be just fine. I'd be happy with that.
Was that your drink of choice and growing up?
It was actually, and Canadian beer was the higher quality beer. So Molson, Canadian Labatt's.
So the final tallies come in. Mike, you finished the 3 months with a total seasonal score of 33 points out of a possible 150.
That's not good, Zach.
That's not good. I came in, I was winning up until September, and you outpaced me by just enough. I had 30 total points. And Ben, who was running last among everybody, it seemed like, had a decent showing for September and came in at 21 points. So that is congrats to you. I can't remember the last time I actually won a bet.
Let's just be clear that no one won. There's no joy in getting cans of beer from you guys after this summer. It was terrible.
That's true. You may be a winner, but it's there's not much solace you can take in that.
No, none.
But there was another winner, and so we do have the winner, which is the winner of everybody that entered at least 2 seasonal values, and so that goes to Aaryn with a total of 56. So Aaryn, spelled Aaryn, actually claims we owe him some Southwest Climate Podcast swag. Mike,
he crushed it. That's a point score way above our playing range there.
Well, he didn't play July, and so we might have to tweak our rules a little bit next year. He did play August and September and absolutely hit a home run in September with his climate cynic approach and scored 36 points. So I don't know all of the values, but given that Tucson, Phoenix, and Flagstaff all had 0 rain, he must have been extending. He must have done forecasting of persistence and just extended the trend forward. So
I think that was just a super bullish, super cynical guess at that point. I get it. Aaryn might have known that it wouldn't rain, but that's a gutsy forecast.
Yeah, but so this is what I've learned. I don't know if you learned anything by doing this little exercise, and I
learned nothing.
I actually think I learned something. And that is, I have no idea why I didn't take the signals that were present in July and August and just extend them. I mean, I don't think a complete turnaround or a reversal, if you will, of those trends in July and August is feasible. Not maybe it's just really unlikely.
I don't know, man. It was totally possible based on the historical distribution to turn it around.
I'm not sure about. We should look into this because I want to know like how predictive is the accumulated precipitation of July and August for September.
I ran the numbers prior to the season, and July and August are not correlated with each other.
But total both. Didn't you do them individually?
I did do them individually, yeah. But you're saying that if July and August were dry, then September might be dry too?
It's more likely to be dry.
Yeah, I don't know, man. I mean, and this is a discussion for another time, but that little project we're working on in the background, the September precip events are completely different in character and nature, like even what causes them. Right. So they could creep out of nowhere.
Well, that's true, but part of my thinking is also based on the fact that there were signals that the tropical Pacific was not as active as well, and so that should have figured into a more pessimistic forecast for September. And I didn't go all in on that, and I'm not quite sure why.
When did we make we had to make our prediction? When did we make our September prediction? Do you remember the date? I can't remember when.
It was at least 10 days prior to September 1.
Yeah,
so.
I felt like it was just outside of that window of seeing how September predictions were going to play out.
It would be less likely for us to win among those who can actually vote knowing, the 10-day forecast. That's a third of the month. So this is all to say that this was a great trial run. I think we had something like 79 different people play at least 1 month.
That was super fun. Yeah, totally. Yeah.
And it was even fun in a season in which it wasn't fun to play.
Good to trial run it to see how things would play out. Absolutely.
I was surprised that we still had momentum among participants coming in this July because honestly, people stopped, including us, our Slack banter went, plummeted as, the monsoon sort of fizzled. So we'll come back next year with a version 2 of this. I'm not sure exactly what that will look like, but it will be similar. We'll have a better interface, I think. So thanks everybody for playing, and we'll reach out to Aaryn, or Aaryn spelled Aaryn in case he's listening, can reach out to us, and you get a mug or a t-shirt on us. So congrats to you. And Mike, hopefully we can hang out pretty soon and we can share a beer together.
I'm looking forward to it.
Might be 2021 though. Late 2021.
2021. Yes.
Okay. So just really quickly, there's not a ton to talk about the monsoon in September, but I do want to just preface this by just summarizing the entirety of it, because we have this new metric that you worked on, Mike, and you were able to tally rainfall using gridded data for the entire monsoon region. So all of Arizona and a little bit, you sort of define the monsoon region based on an analysis that you're doing that conforms with the way that other people have defined it. So it includes a little bit of Western New Mexico, so not all of New Mexico, but basically looking at that area and all of the rainfall averaged over that area for the entire season. Drum roll, please. Not unexpectedly, this year was the driest on record.
That's correct.
Mike, what the heck happened in September?
Nothing. Nothing happened. Something probably did happen, but I didn't even have the heart to go back in and look to see what the month played out. And, just as you pointed out, the analysis that we're cranking in the background that'll hopefully be ready by next summer, I took Western New Mexico. So it includes just past Albuquerque, and it has El Paso. So it has all of these cities that we were actually, using for our precipitation game. And, what was striking is how all the cities fell together this summer. And that puts you, when you look at this whole region, in very rare territory. So the average sort of aerial precipitation for this region for July, August, and September was 1.81 inches. And the previous driest July, August, September was in 1956, was 2.36 inches. So that's quite a bit lower. And I think some of us remember the summer of 2009. 2009 was actually the fourth driest. So we were way drier than that, which was at 2.75 inches. So that it's just epically bad. And and again, this is since 1900, the data that I'm using. So 1900 through 2020. And it does not take into account the sort of paleo variability, but in the instrumental record, this is the worst summer we've seen.
Yeah, and just to put that in context, the wettest aerial average is close to 7 inches. It just puts that in context a little bit. But also, I mean, it's astonishing, a half an inch between the driest 2020 and the second driest 1956. So that's, absolutely, as an aerial average, I mean, that's not just hitting a home run. That's like hitting it over whatever parking lot is adjacent to the ballpark.
Totally.
I wish I watched baseball because I would have actually had a specific park to
yeah.
Right. So yeah, I mean, did it rain anywhere in September? Because it didn't in Tucson at the airport. So Tucson came in at its driest on record. Let's see. Phoenix was actually, believe it or not, this is surprising to me, it was actually the 8th driest on record. And what is most surprising is, and this, I feel sorry for Phoenix. It only rained twice at the airport all year. It's hard not to laugh. These numbers are
You're sick man.
2 times. I mean,
wait. Let's back up. It rained twice in Phoenix since June 15th. Is that right?
Yes, twice. Okay. June 15th.
And what's the rank?
So the precipitation rank is only 7th driest. 8th driest. 8th driest.
8th. Okay.
So Tucson number 1, Phoenix number 8, Flagstaff number 1. So second year in a row, it's been the driest on record. So
the driest last summer, and it was even drier. So it broke the record that was broken last summer.
That's right.
Flagstaff did
back-to-back records.
Back-to-back records. Yeah.
Way to go, Flagstaff. Yeah, New Mexico wasn't as depressing, but still very dry. So Albuquerque came in at the 10th driest, and El Paso came in at the 6th driest. So what's astonishing here that you just mentioned is it's dry everywhere. Normally that doesn't really happen.
Exactly, right. And so I remembered, because I kind of blocked this out of my head when I had written something up about a week ago, was that there was one precip event in September, and it was over the kind of the 8th and 9th of the month, was related to, I believe, some of the fire activity in California. But there was a very strong, cold, low pressure system swept out of Canada and dropped straight south towards the Four Corners. And it snowed in Colorado.
That's right. It snowed a lot in Colorado.
Yeah, it snowed a lot in Colorado, right? And so
it went from an excessive heat warning the day before to an excessive winter storm warning.
Winter storm warning. Yeah, it was one of those like 84 to like below freezing in one day. And so Arizona picked up a little bit of storm activity just as that cold front came through. And then New Mexico actually picked up a bit of precipitation, not a ton, but sort of widespread frontal precipitation. So that is like not monsoon at all. That doesn't have anything to do with the monsoon. It was, I don't even know if you want to call it a transition event at that point. It's just a little bit of leftover moisture interacting with an early season cold front. But that was it. I mean, that was effectively the only meaningful weather event of the whole month. And other than that, it's been high pressure. And thankfully, if we're not going to do the monsoon, at least the dew points fall. And they have fallen quite a bit. But the heat is continued, and we've continued to do 100-degree days down here in Tucson. And, we continue to break records as far as the heat.
Through the end of August, actually, the number of days 100 degrees Fahrenheit or above in Tucson was record-setting. So 100 days. In fact, that's the full year. The previous full year record, obviously, like moving forward, it's we don't have many more of those 100-degree days left, but the full year record previous to this year was 99, and through October 1, there had been 100. So 2020 has the record setting for Tucson, and the same Phoenix. So this was updated. This graph is updated by National Weather Service in Phoenix. And through October 9th, 2020 has had 141 days of 100 degrees Fahrenheit or greater, whereas the previous record was 139. And the full year record for Phoenix is 143. So it is likely, or at least possible in the next week, that Phoenix will claim the yearly record as well. So yes, the heat has continued. Any like big picture takeaway that you had that kind of changed the way that you've been thinking about the monsoon at all?
I had to give a couple of presentations the last couple of weeks, and so I've really struggled with this. As I've struggled with it, I haven't had any clarity come with the struggle, which is kind of disappointing. I mean, like really kind of spending some time with the maps and looking at some of the data. So I kind of broke it down into a list of things that I think went wrong. And so what I thought was kind of interesting is once you go back through the maps and you even think about the way we were thinking about the monsoon at the beginning of the season, thinking about how the outlooks were being painted and the condition of the El Nino Southern Oscillation at that point, we were neutral, probably heading into a La Nina event. So there wasn't a lot of background conditions that would have given us a strong signal, even though there isn't a super strong signal with the summertime. So we were kind of coming into the season blind with the expectation that anything was possible. It's frustrating to go into a season, as a climatologist, I'm like, okay, we don't know anything. Climatology should be some guidance, right? And then to have the season play out on the tails being so extreme, and then to kind of go back and go, well, shoot, I'm having trouble finding a single silver bullet, right? Like there's no clear background mechanism that really you can point at one thing. So this is my list here, and I think I've shared this with you, but the subtropical ridge, the mid-level ridge, the Four Corners highs, kind of known for the monsoon ridge, known by all these names. So mid-level atmosphere progresses north out of Mexico, kind of following sun angle and surface heating of the continent. And as it sort of moves overhead and moves up to that Four Corners, the air mass changes underneath it, right? And so then we get into the precipitation. Well, that did not really happen in July. It was really late and suppressed. Once it did sort of move in, it moved in fits and starts in August and was then shoved off to the northwest. So that was unfavorable. So overall, this mid-level ridge position, which is an important determinant, it's not the single determinant of a good monsoon or not, really was not, it didn't move in quick enough. It didn't usher in have the moisture kind of follow with it, and then got shoved around and then quickly retreated towards the end of the season. So I think that at least is a diagnostic of what, why we didn't see as much precip all over the place through the season. We never ended up having any of those really good, big, widespread, heavy events anywhere across the Southwest, which become important for causing soil moisture to get replenished at least a little bit and vegetation to green up that can turn into recycling. If we did have any of that, it was quickly dried out. And so the dew points never really climbed to any meaningful level. So the air mass never really turned over and got wet and stayed wet here. We also saw, this happened especially in August, where the monsoon ridge was getting kind of pushed all over the place. There were these cold fronts that would drop down in the eastern U.S. And so cool, dry air would drop down the Great Plains, and we'd have these little backdoor cool fronts, and they weren't temperature-wise, but they were air mass-wise dry. So we ended up having dry air get dragged in here in times when it just wasn't helpful. We're trying to have some Gulf moisture surge in from the Gulf of California, and then the dry air would come and just mix it out, and that would be a mess. We had very few Gulf surge events. We only had a couple associated with storm activity coming across Mexico, and very few tropical storms got into the right position to kind of trigger any Gulf surges. And then finally, we even had a couple of days that this happened in August. I'm thinking about August 3rd in particular, where we ended up having smoke, a pall of smoke settle over Arizona. And it was just enough to take the edge off of temperature that day, where we needed it to get a bit hotter to kind of chip away at the convective inhibition that would have helped fire those storms off. So it was like unbelievable. Like it was like stuff was sort of lining up, and again, this was only like parts of Arizona where the moisture got close enough to be even supporting thunderstorms, whereas much of the rest of the Southwest was completely left out of that because the ridge was in the wrong position. So just like, it's just like a litany of terrible things. And again, 2020, that's all I can
2020, it keeps delivering in the worst kinds of ways. So
yeah, I mean, and again, I think there'll be more sophisticated postmortems done on this, but yeah, it's like there wasn't a strong sea surface temperature signal that I think would have led to anything meaningful in us understanding where the ridge would have went. But the one thing that I did see, and I don't know if you saw this in some of my slides, was the Indian monsoon for the second year in a row was above average. And there is in the literature, and this is in one of the there's a couple papers that talk about the circumglobal teleconnection that does seem to be related to, you can get these wave patterns that go all the way around the globe related to enhancements with the Indian monsoon. I don't know. Like, is that part of this story? The postmortem on this will be really interesting.
Yeah, I kind of felt like I was looking for a metaphor, and I kind of felt like it was like trying to start a car that has a dead battery. And, it's like it's kind of ramping up and like you're pumping, or at least I was when I was driving cars that would, whose battery would die. I would be pumping the gas to try to like get it to kick over. And it just felt like that was the case this year. And quite frankly, it felt like that was the case last year a little bit as well, but for entirely different reasons. Last year, it was just like the moisture was around and we just didn't have some of the other atmospheric dynamics to really pop it off. And this year the moisture just wasn't around, but it was
interesting because it was close. I mean, there were times where the moisture was literally just south of, it was in Mexico, and it was even sustaining some precipitation in Mexico. And we should note too, that most of northern Mexico did not have a good monsoon either. So it wasn't like it just shut off at the border. It was like overall, the whole North American monsoon system was suppressed.
So quick question. This just popped into my head, but the Atlantic has been really active this year in terms of hurricanes. And so is it odd that an active Atlantic that would have, some easterly waves, maybe more active easterly waves coming across, would also produce, and those easterly waves that don't turn into hurricanes and that can move across Central America and northern Mexico or southern Mexico, would then instigate those Gulf surges that would be helpful for starting up the monsoon. Is it strange that with an active Atlantic that we just didn't see active sort of monsoon surges and easterly waves?
As you probably have noticed, I'm a kind of a wishcaster. Like, I always have in my mind, like, ooh, cool, all these awesome things are going to converge and give us this awesome monsoon. So that was one of my things at the beginning of the season, was that the outlook for the Atlantic I thought was going to be really favorable for us. It's only favorable for us if the overall ridge is in the right position, right? So the ridge actually has to be north of us or off to the northeast of us, and it has to be north of us to have the easterly waves actually ride underneath the ridge, right? Because otherwise they just get deflected and blocked. They go to the southwest, and they'll go through sort of central Mexico. And what you saw often in the Gulf of Mexico too is this sort of tussle between really frequent activity in the Atlantic and waves coming across with the troughs that they were having in the eastern US, which would end up dragging dry air all the way down south through Texas and then even across the northern Gulf of Mexico. So they ended up having these really sharp contrasts between very dry, very wet, very dry, very wet. So yeah, it could have been really beneficial if we would have had a good, strong subtropical ridge sprawling high across the west, where we would have been on that southern limb of it, and it would have come across and given us that opportunity.
I took this as a little bit of a small opportunity to catch up on some literature that I'd read in the past but needed to revisit, prompted by numerous questions. Again, I got this like last week again when I was talking with Bill Buckmaster on his radio station. And we talked about the question of is this year a harbinger of the future under global warming conditions? And, my take, and I think your take too, and we talked a little bit about this previously, is that can't really say, in part, definitely can't say actually. I feel pretty strongly about saying that there's a fair amount of uncertainty around future monsoons for a number of reasons, those being the tools that we have. The global climate models are just not high resolution yet enough to really sort of map out the spatial and temporal dynamics in their complexity that they deserve. So one of the key things is that even the smallest models don't resolve topography in the way that they need to, and topography plays a key role in creating that atmospheric instability. Also, like for Arizona and New Mexico, we're on the northern fringes of it, and there's a whole bunch of different processes at not only regional scales, like the position of the ridge, but also like really localized convective kinds of processes. And there's a whole bunch of those things, and that they can oppose each other, they can reinforce each other, and it becomes really hard to parse out which in that tug of war actually wins out. And then just looking at past historical analogs, it's at least in the observational record, it's unclear how it would unfold. And I think we said this, and I think this is your take as well, prompted again by questions of is this a harbinger of the future? I sort of went back and read a couple papers that we could briefly talk about, Mike. One of them was really cool that you pointed me to, which was by Angie Seth from University of Connecticut. Let me see if I can't pull up the title. So it's Monsoon Responses to Climate Changes, Connecting Past, Present, and Future. And it's 2019 in the current climate change reports. And they basically were asking the question, well, is there anything that we can learn from the past, the deep paleoclimate, that might provide some analogs for the future? So they go back over geologic timescale. So they're looking at like the Pliocene, which is 3 to 5 million years ago. They're looking at the last interglacial and the Holocene and the Quaternary rather. So that's one of the questions that they tackle. And they were looking at the monsoons it was a literature review looking over the monsoons, not just the North American monsoon, but in the other regions as well, including the Indian monsoon, the China monsoon, South America monsoon, and the African monsoon. That's a really interesting paper worth looking at for people that want to sort of dive into this topic a little bit more. From past analogs, now they're all imperfect past analogs, but during, let's say, the Pliocene, like 3.5 million years ago, the atmospheric concentrations of greenhouse gases were close to what they are right now. In fact, really close, 400 parts per million, which is a little bit less than we are right now. And it was a warmer climate, so it was similar, but the difference then was that the climate was equilibrated. And right now the whole system is sort of responding to this thump of greenhouse gas forcing and this warming. So we're in this sort of transient phase. So it's not a perfect analog. But in that period, the monsoons in Asia and Africa were actually wetter. And then they also looked at the last interglacier, when temperatures were warmer than they are presently, but there wasn't any ice, or there was less ice than there currently is. The monsoons were responding, not the North American monsoons, but the Asian monsoon and the African monsoon was responding a little bit more vigorously. So the past record might suggest imperfectly that a warming world might bring more rainfall. But then they also looked at the climate models, which under a variety of different experiments, and what sort of played out was that there'd be this delay in monsoon onset. And again, we're talking about all of these months. So thinking about the monsoon systems, not any one in particular, but just how the monsoon systems as a circulation feature that's inherent to the climate system sort of evolves. That one of the not robust findings, but one of the findings is that the monsoon itself may sort of delay in its onset, but would pick up more vigor in the latter half of these monsoon systems. They summarize their reports out in the North American monsoon just for the future, and sort of a mixed bag. Some called for a slight increase, and a few other studies called for a decrease. This is long-winded, but maybe it'll be of interest to some people because I really felt like I needed to wrap my head around what the state of the science was saying about global climate change and the monsoon. So that sent me to a second paper that was published in 2017 in Nature Climate Change by Salvatore Pascal and a bunch of other authors, titled Weakening of the North American Monsoon with Global Warming. So this is not looking at all of the monsoons as the last paper did, but focusing specifically on the North American monsoon in its entirety. So again, it's looking at the North American monsoon, which includes the core of it in Mexico. They only looked at one model, a model that replicated the seasonal pattern of the monsoon region pretty well. So they were discarding a bunch of other models because and focusing more on the model that did a best representation of the seasonal signal here in the North American monsoon region. And one of the things that they had noted was that a main problem with these climate tools has been that the sea surface temperatures are biased. And so it's biased a warm signal, and that can really screw up how the monsoon systems respond. So they did a whole bunch of different experiments and were able to correct in part for that bias. And when they did correct for that bias, it turned out that there was what they call a robust drying signal for the future North American monsoon. Now, I think it's also under it's a doubling of CO2 concentration. So they looked at a doubling of CO2 concentration from pre-industrial. So that would be something on the order of 560 parts per million. So in the future for us, and when that remains to be seen. But they found that when they corrected for the sea surface temperature bias, that there was a statistically significant drying signal that they then attributed to this change in convective stability. So the atmosphere actually becomes a little bit more stable, and you can't actually create that convection that's needed to parse out or to squeeze out the moisture that's there. They didn't actually quantify change in moisture around. And that was one thing that would have been helpful, but just more, they were trying to answer the question, well, what's driving this drying signal? So my take on all of this is to say that I'm still not completely convinced of what the future will hold. I still maintain that our science tools to look to the future for the monsoon have still a ways to go before we can be more clear about what might happen, that this year is not a harbinger of the future, but nonetheless, I thought it's worth highlighting that there is some indication that perhaps the monsoon may get drier in the future. Mike, I don't know if you have any, after that long ramble, if you have any take on what a monsoon in a warming world may look like.
Yeah, no, that was a really good synopsis, I think, of those papers. The papers that I've read too, because I think we're both really interested in this, is to try to do some real-time attribution, but real-time attribution is really hard to do. And so to answer the question that's posed, what are the climate change forcings on this summer, you'd have to do a formal model attribution exercise, right? And so those are being done, and I don't know if anyone will do it on the monsoon. But as you were pointing out, the monsoon is difficult to model under any circumstance, and multi-model ensembles tend to mix out and mush up a bunch of stuff and don't quite resolve it. So that paper, as a single model, had to do some very specific things to try to replicate some of the monsoon dynamics. And even then, it does miss out on some of the fine-scale topographically driven parts of it, which are really, really important for a lot of the monsoon precipitation. So I think that if somebody did do that, I would expect that the climate change contribution to the dynamical part of this would be small, and that the natural variability would be the biggest explanation for this summer. But I want to make the point, though, that it didn't rain here, and we didn't have the moisture on the ground, and we didn't have that sort of evaporative feedback. So all of that led to incredible sensible heat fluxes. So a lot of, which gave us the record temperatures through the summer. So I do believe though, and I think that if you did an attribution exercise, is that we would not, in previous dry monsoons, they would not have been as hot as this summer. So the climate change expression this summer really, I think, is through the temperatures. So not raining set the stage for it to be much hotter than it normally would be when it was raining. That's just kind of an obvious thing. But the fact that we're in this changing climate, the temperatures are so much warmer than they would have been in past dry monsoons, I think is important to. If
you would have placed the rainfall pattern that we experienced, or the lack of rainfall pattern that we experienced in 1920, for example, or 1940, the temperatures would have not been as warm.
Yeah, I mean, 1956 is, I think, that was a good analog, maybe. It was dry, and we were warmer than 1956. Not a lot warmer, but enough that I think the climate change aspect is on top of that.
So what about in that paper, the second paper that I talked about, the Nature Climate Change paper, it talked about the changing atmospheric buoyancy, or we've talked about this before, mentioning CAPE, convective available potential energy, basically like the stability of the atmosphere in a warming world. And according to this paper, it becomes more stable. What do you think about that as a likely or possible future change? Any thoughts there?
It's they say, it's sort of a robust response, and again, it's doubling of CO2, which I really hope we won't see, right, by end of century. So we'll see something less. So to get that robust response, you have to have doubling of CO2. Probably going to see something lower than that. And then atmospheric stability is really heterogeneous across the landscape. And it has a lot to do with where the moisture is, and moisture at the surface. And we think about column integrated moisture through precipitable water can do wonders for driving atmospheric stability. This is where I feel like it's those models have to get very, very fine scale things right to be able to have these really, I think, robust responses for the whole season into the future. So, patterns of moisture availability related to Gulf surges, which there's another paper by Pascal that suggests that Gulf surge events will actually decrease. And, that's also, I think, what some of Chris Castro's work suggests too, is that the easterly waves will be suppressed south and the triggering events might be less. I think there's still a lot of really nuanced moving parts there that aren't sorted out, that don't give me a ton of confidence that the whole monsoon system is sort of moving away from being what it is right now into the future.
The moisture that's present would affect the atmospheric stability or instability. And we can't really do those that well with the models. And so I don't have a ton of confidence in changing atmospheric stability if we can't really understand what the amount of moisture will do in the future. And that is also impacted by changing sea surface temperatures in the Pacific and a whole bunch of other upstream issues as well, including these easterly waves. So yeah, I think you're right. I mean, I think it's like, and they admit in both these papers, I mean, they admit that the uncertainty is high, in part because it is such a complex system. So
yeah, I mean, it's not good that most of the studies are actually leaning towards drier. I think that there's a little bit of lean in the literature towards the system not getting wetter, which I think is interesting. I'm not totally sold on the whole thing as well too. And if you even look at like this summer, there were times when the mid-level ridge it got big and sprawling, and it was just kind of hot everywhere. Well, that's also, convectively, can be convective inhibition too. So, there's some suggesting that the ridges, and the geopotential heights, or the temperatures in the mid-level atmosphere, were just enormous. They were through the roof, right? And a lot of it had to do with the fact there wasn't any rain occurring, and there wasn't water kind of getting, mixed through the lower levels of the atmosphere and cooling it off and those kinds of things. So that could also be sort of a signature showing up in some of the projections going forward, is that that's part of that convective inhibition. The variability within a season can be very, very high. And we also need to recognize that Arizona and New Mexico are on the northern fringe of this system. So we're already predisposed to having enormous amounts of kind of intraseasonal and interannual variability. And my final point is that the last basically decade have been okay monsoon seasons for the Southwest. So It's just this year and last year that were not great, right? But every year prior was near average or above average for the region as a whole, right? Not every specific location. And it was 2009 was the dry year in that. And if you look at the previous 3 years prior to that, they were near average to above average. So in the last almost 15 years, we've only had 3 seasons that were, really quite dry. And that's not normal in the whole historic record, right? Just in the instrumental record, we've got runs of years that were below average. In the early 2000s, we had, numerous monsoon seasons that just weren't great for the region. So we've got a little bit of recency bias here and recency expectation for the system, I think.
This was an extreme year, and one of the hallmarks of, or maybe the robust findings of climate change is that the extremes will enhance. And so there's a tendency when we're in these extreme years to look toward the climate change as the cause. But I think that there's probably a lot better examples of climate change impacts than this year's monsoon season. So
I completely agree. I mean, climate change is the gorilla in the room. We need to address it. I don't think we're going to be able to do pure attribution. Climate change isn't 100% cause anything. There are a couple of impacts that are really close to that now. Acidification in the oceans and in some
melting
of the
glaciers, which are near and dear to my heart.
But the monsoon is so far on the other side of that where it's so hard. And again, it's not to say zero. I'm sure that there's some percentage of attribution to why monsoon failed this year, but I bet it's low. And then it would be temperatures on top, temperatures gets a little bit more of that attribution. And then, that's probably all we can do.
All right. Well, I look forward to your attribution study.
Dude, that's not me. Yeah. This is a call out to all of maybe we can crowdsource some attribution studies now from all of our, of all of our game players.
All right. So I'm going to say this, let's not talk about the 2020 monsoon again until 2021.
I think that's right. Should we though? I think the final last little bit here is I think we have to recognize to try to look forward here. We've done how bad it is, but now kind of pivoting to the drought part of it. What was the next? Is that what we're okay?
Yes, that's what we're pivoting. Okay. You're right. So I guess we still have to refer to the monsoon. Darn it.
We do.
But before we do that, Mike, let's take a break and hear from our presenting sponsor.
Who is it this time?
I've always wanted to say that. We don't have one yet.
I was actually really excited for a moment if it was going to be like the ShamWow as seen on TV car wash kit or something like that.
No, I just always wanted to say that.
That was good. That was really, really well done.
It's just me.
It's just Ben. Ben is our sponsor.
Yeah. Our parents have contributed.
Exactly.
Okay. So yeah, I think we would be remiss not to put this monsoon season in the context of what we're thinking about upcoming for the winter. It puts a lot of pressure for wintertime rain because back-to-back dry seasons really set the stage for, maybe it's this, Mike, like how much has this monsoon season set the stage for drought impacts?
Bad. We, as climate and weather enthusiasts, we kind of relate to the weather in a kind of a fun way, but there's a lot of, there's residents and farmers across the region and land managers who are out on the landscape and they're really suffering right now. And you can imagine the wildlife are in trouble and there's a lot of resource impacts across the region right now. And part of it is because 2019 summer was dry. So there's that lingering. Last winter, we often forget, was actually quite good for Arizona. So November through March precip actually set the stage for some really good spring wildflowers, but that did not take all the edge off of some of the lingering impacts from last summer. And then this summer is actually absolutely devastating for some, like rangelands and livestock producers are in real trouble across the region. And so they're selling livestock. And it's really hard now to be in this situation and to look forward as we're talking about a La Nina winter coming up, because we don't have record or very dry summers often followed by very dry winters. It absolutely has happened in the historical record, but especially in the last 10 to 20 years, we haven't seen too many situations like this.
Well, so let me put some numbers to that. So just looking at Arizona now, going into the monsoons at the in the middle of June, according to the U.S. Drought Monitor, 67% of Arizona was drought free or completely abnormally dry or some drought classification free. Fast forward 3.5 months to the end of September, and 0% of Arizona is free of drought. In fact, 100% is of moderate drought or worse. And the 70% of the state is under the second highest drought category, extreme drought for Arizona. So that is an exceptional change of conditions, frankly. And it's a picture that is, when you look at the West in general, it is not as bad in other states. New Mexico, for example, the only other state that experienced perhaps as close of a deterioration in drought conditions is Utah. But Utah coming into the summer was under moderate drought, and nearly all of its area had some drought classification. It just intensified drastically there. So Arizona, in terms of drought picture of the West, is really the bullseye in terms of change. So it's not a good scene. And so I guess my question to you is, maybe this is rhetorical, but is this an appropriate escalation of drought conditions across Arizona in the West? Do you think it's a little bit underplayed or even overplayed?
I don't think it's overplayed at all. I think that the challenge of the drought monitor map is now it's this kind of amalgamation of different timescales of drought. And so as you were pointing out, the upper Colorado River Basin did not have a great winter. It was really sort of southernish Arizona and parts of New Mexico that picked up a lot of the precipitation. The Four Corners and much of the upper part of the basin did not have a good winter. So as you were saying, they're kind of already moving into this. And then, the abject failure of the monsoon, which does deliver some precip to Colorado and Utah, not a ton, but that just kind of, caused conditions to deteriorate further. And then we quickly, since it is for parts of Arizona, a very important part of our seasonal total. So we're all now at this D3 extreme drought, just shy of D4, but we're now starting to see pockets of D4, which is exceptional drought, which it should be drought that occurs kind of once every 50 years as far as its frequency. So, which is, again, we're at the beginning of October, staring at a La Nina event that's already in play, already, drifting towards probably moderate strength, expected to intensify over the next couple of months, which gives us a pretty reliable wintertime drought signal. So there's not a lot of room left for this drought monitor map to get worse, and we're at the beginning of this season.
This is a story that we're going to be following because, La Nina was always sort of hinting at coming. It's now here, officially designated as a La Nina. The forecast blogs that I've read indicate that it will sort of merge on moderate to strong, which, a few months ago, while there were signals for La Nina, I think, at least in my recollection, it wasn't looking like a moderate to strong event. Yeah, and in terms of the atmospheric response to that, the stronger the event, it doesn't necessarily mean that that precipitation will be drier. but it just increases the probability that there will be dry anomalies or deficits. So that is not a particularly favorable situation that's developed. And there's cold water in the subsurface in the tropical Pacific Ocean, which gives forecasters confidence that the La Nina is going to persist into the fall and winter. So it's not going to be like a short-lived dip in, dip out kind of thing. It'll likely persist into early 2021. And then, all of the models, Mike, from the North American Multi-Model Ensemble forecast dry conditions for our area. Now, obviously they're picking up on the La Nina signal, but this is as robust as a forecast as you can get. I feel like. I don't know what do you see?
This is one of those situations where you just try to think about the next couple of months through the winter. What kind of storms could you even sneak in here in these situations, especially as it gets a little bit pushed on moderate, and even if it does tilt into something a little bit stronger than that, it's such a reliable dry signal for the Southwest. It makes the storm track, it challenges the storm track so much to bring any precip down here. We don't have to think back that far. Like 2018, that fall of 2017 and into winter of 2018 was very warm, very dry, and we only had one meaningful precip event for southern Arizona, and it was a really strange kind of atmospheric river that came up out of nowhere straight from the south in February. I don't know if you guys remember this, but it was super dry winter, and then we ended up having a super warm, wet system right over Valentine's Day of 2018, and it rained for like 2 days and low clouds, and it was wet everywhere. And that was it. It was like the only event of the whole winter. And that's like completely unpredictable. And it was such a strange event coming out of it. And, the past years of this kind of magnitude of La Nina events it's not a great bunch that you want to be associated with. It's got 2011, I think, is in there. 2009 was in there. 2006. So 2001. So these were dry years.
And these were La Nina years. Did you say that? I missed that.
Yeah, they're La Nina years.
Yep. Now, did any of those follow a pretty dry monsoon season? I'm just thinking about an analog here.
Okay, so 2009 was in here because it was a La Nina event in the previous fall, winter. But I don't know if you remember this, but 2009 was a really weird where it went from La Nina and quickly switched over and turned into an El Nino over the summer. And so part of the attribution of why 2009 tanked, it rained a bit in July, but it completely shut down in August of 2009. And we were actually moving into that 2009-2010 El Nino event that ended up being quite wet by December that year. So it was just kind of like up and down variability. So I guess I don't even know if this is a bright spot or not, but if this is a strong event and it actually lingers all the way into the spring, and it does linger into the summer, that would give us a sea surface temperature signal to possibly think about an earlier start to the monsoon season.
Are we already forecasting?
Yes. I came out of my mouth and I was like, this is absurd.
All right, so let's play this out. Right, so in southern parts of Arizona, New Mexico, the winter season is half our rainfall, 40% to half. And we need to make up quite a bit of deficits from the monsoon season. So let's say it's similarly, 50% of average. I mean, that really puts us in a bad state for potential fire risks for our next fire season, springtime fire season into early summer. It's hard to say about the water because a lot of our water comes from the Rocky Mountains, and the ENSO signal is the jet stream can dip down and bring snow and rain to lower elevations even during the La Nina year. So they don't experience the same kind of strong signal with a La Nina that we do. So water is a little bit of a, of a, of a mixed bag there in terms of, you know, the Colorado River and the Rio Grande.
But one point too, though, is that, there's been some recent research here too, is that fall precipitation becomes an important precondition for stream flow the following spring, right? So if there is real strong soil moisture deficits, that can actually soak up a lot of precip that won't turn into stream flow in subsequent kind of runoff seasons. So we're really running behind here across the whole kind of upper and lower basin now in the Colorado. And so even if we get rain, you're going to be throwing rain into very, very dry soil for, I think, quite a while.
I'm looking at under the hood of these models for the North American Multi-Model Ensemble, and for both the November, December, January, and December, January, February period, they're all pointing to drier than average conditions. So you certainly don't see that obviously you don't see that in the summer season, but normally there's at least some outliers here on these models, but boy, I don't know, Mike. I'm not too optimistic about this winter, and I think that's a really really hard position for us to be in.
It is. It's a bad spot, and it's just one of those where I don't know. The seasonal forecasting is a tough gig as it is, but the La Niña events they're really pretty solid. Gosh, the podcast started off of the 2011 one, didn't it? The 2011, the La Niña tracker all the way, back a decade ago.
Boy, and I can't believe we've been doing this for that long.
We were in the same spot looking forward, but we didn't come off of such a bad summer. And that's why I think that this is.
Well, that's right. I think that this is, we've never been in this, you and I, as talking through this, we've never been in this kind of situation.
Not quite like this, no. So we'll have a lot to talk about, and none of it will be fun for the next couple of months.
For the next, just to give a nugget of what we're going to talk about next podcast, we thought we'd dive a little bit into the fire situation, which has been so dramatic and dire particularly for California. We had a really bad fire season in Arizona as well. And California, as many people know, has been the epicenter. More than 4 million acres have burned, which squashes their record by a long shot. I don't recall offhand what the previous record number of acres was, but I want to say it's around 2 million, maybe 3 million at the most. But anyway, it's been shattering there. And there's been some interesting things that I've learned along the way, just like how, a large fraction of the burned areas this year have been burned previously in the last 20 years. So it's not like there's a recurring burning going on. And so there's a lot to unpack there. And of course, like there's the whole Santa Ana winds, which is really the sort of atmospheric phenomenon that really amplifies the situation. And obviously you have the background, the climate, which sets the background conditions. And it gets into, land management and people. And so it's this complex social environmental system that is really, really kind of interesting to intellectually think about. And of course, obviously the impacts are just absolutely tragic. So we'll spend some time on unpacking that next podcast in a month. And we'll also have a little bit more to say about how conditions have evolved with La Niña and in the drought and, rain. Hopefully, maybe we would have seen an early season transition storm. Probably not. Mike?
I don't think so, man. Should we start betting on that now? I think I'll bet one of my 4-packs that it doesn't rain in Tucson between now and the next podcast.
Can I delay when we do the podcast?
No, you can't. You can't drag your heels, and you can't use the forecast to schedule around it too. You and Ben cannot coordinate on this.
No, I'm not taking that bet. But who's your football team? Do you watch football?
So I'll watch the Lions on Thanksgiving. That's just the.
This makes it all better. You've had a long life of hardship.
Exactly.
You can gloat with your, with your Monsoon fantasy victory.
That's all I have, Zach. Yeah, that's all I have. So, and yeah, on the fire thing too, I think Arizona might have a perpetual fire season this year. So we may end up tracking fires all winter long. I don't know if you guys, but I ended up smelling smoke as I was going to bed last night, and I was like,
there was smoke around. I was riding last night, and I was like, What? More? And and so obviously that's from the West Coast, right?
No, this is a fire that's down near Arivaca, right? A 5,500 acre fire kind of burning through brush down there, and the plume of smoke was just going right into Tucson. And yeah, because I thought it was California too. I was like, oh my gosh, it's just this won't end.
We'll dissect fire, and we usually don't do it at this time of year, right?
We usually don't have to, right?
Yeah. All right. Any final parting shots, Mike?
No, it's just it'll end at some point, right?
It'll be okay. Is that?
It'll be okay. Maybe that was what I was.
It'll be okay, guys.
I was struggling for the right words. It'll all be okay, eventually.
I was really hoping, that we did, the 5 stages of grief last time for podcasts, and I was thinking about, the fact that we didn't have to talk about the monsoon again as maybe being the 6th stage of happiness, but given that we have La Niña, I think we're going to have to wait a little bit of time before we get to the 6th stage, which is happiness.
We might just have to put 2-minute meditation breaks in the podcast and in different spots too.
All right. So, those meditation apps, we're looking for a presenting sponsor. So
man, you're going hard today on that.
Well, happy Friday. And thanks to, Ben for putting this all together, and everybody else for tuning in, and thanks for people for participating in the Monsoon Fantasy. And we look forward to doing more of that. So everybody have a great weekend, and we'll come back at you in about a month.
Take care, everyone.